Welcome, Math Geniuses. Today we're looking at the Pythagorean theorem. Hopefully you'll be able to use the Pythagorean theorem to find the side lengths or the hypotenuse of a right triangle. Quick review of what a right triangle is. It's always going to have this right angle. They usually put a perpendicular symbol in there, and that shows where the two legs are. This is a leg over here. There's a leg over here. The longest side, which is always across from the right angle, that's always called the hypotenuse. Always the longest leg of a right triangle. Interesting fact for you. Pythagorean theorem, you may have seen it in several different ways, looking like this. I do not like this method because every so often on the ACT they'll change this side length to a B, they'll change this to a C, and people will miss the question more times than not. So I try to think about it like this, just thinking the hypotenuse squared equals the leg squared plus a leg squared. That's really close to the way that Pythagoras, the inventor, actually wanted his formula to be said. So in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Let's take a quick look at some of the ways that this might show itself. I'm not going to work out every problem. We'll just work a couple of them. If we don't know the hypotenuse, we can say that that's going to be x squared equals, that'd be 45 squared plus 24 squared. Very straightforward here. I'll make sure to square everything. When you do this, you'll combine these guys with your calculator, and hopefully you'll get 2601. Then when you take the square root of both sides, it actually comes out to be a really nice number, which is 51. If there were units, we'd want to use those units on there. Next problem is pretty similar. You'd get something like x squared after a little while will equal 325. We'll have to take the square root of this, and we'll look for really nice numbers to come out of this. This would be 25 times 13, which gives me 5 and 5. Since we have a pair of 5s, this becomes 5 times the square root of 13 is my value for x, if I'm trying to put this into simplest radical form. Again, some teachers will accept decimals, but if they ask for the simplest radical form, that's what it's looking for. Down below it says find the length of the hypotenuse. So up above, they gave us two legs. We had to find the hypotenuse. Down here, they give us a hypotenuse and a leg, and we need to go find the other leg. So for us, we'll just write this as 27 squared equals 9 squared plus x squared. 27 squared, when we subtract the 9 squared from it, this would give us 648 equals x squared. When we take the square root of both sides, that would break down into, let's see, probably 18 and 36, which would then break down into, let's see, that'd be 6 and 3, this would be 6 and 6. So probably, oh boy, where are we at with this? Oh, we probably need a couple more numbers. 18, so this would turn into a 3 and a 2. So we'd have a pair of 6s, a pair of 3s, so we'd have 18 times the square root of 2 is what x would equal when we take the square root of both sides. Pretty similar thing happens over here. We'd have 25 squared equals 18 squared plus x squared. That would give us 301 equals x squared. And when we take the square root of both sides, 301 does not simplify, so we just have x equals the square root of 301. Extending this just a little bit further, we can talk about area. An area of a triangle is not really a big deal. The first step we'll do is we'll find this length, and then we'll apply the formula for area, which is 1/2 base times height. So not a huge deal here. We'll just say that's 28 squared equals 12 squared plus x squared. When we do this, we will get 640 equals x squared, or x equals, let's see, that would be 8 times the square root of 10. We'll then apply the area formula, 1/2 base times height. That would give us 1/2 of our base, which is 8 times the square root of 10, times our height, which is 12. In fully simplified radical form, we would have, let's see, half of 8 is 4. 4 times 12 is 48, so we'd have 48 times the square root of 10. And since these are meters, our units would be square meters. This problem will work out very similarly. So let's move on to one of these two down here. What you have to look at here is we have an isosceles triangle. That just means that these two sides are similar. It means that these two sides over here are also congruent, these two angles. So what we're going to do is we're actually going to say this altitude, we drop it down, and that makes these two sides congruent as well, making this length 24 and this length 24. What we do then is we use 44, 24, and h for this, just maybe the right side of the triangle, and we'll use that as a right triangle to try to find the value for h. At that point, we can apply the distance or the area formula in order to find the area of this entire triangle. So let's try that. We'll say 44 squared equals 24 squared plus h squared. That would give me h squared equal to, let's see, 44 squared minus 24 squared gives me 1,360, and I'll find h to equal 36.88 approximately. I'll use my area formula. Area equals 1/2 base times height. That would be 1/2 of 36.88. I'll actually use this entire decimal in my calculator. I'm just abbreviating it so I have something to write down. Times a height of 48. Actually, the base is 48 and the height is this number. My area to the nearest, I guess, hundredth would be something like 885.08. Again, we have square meters if you're looking at that. Some people will have you round to 3 significant figures, which will just give you 885. Some people will say nearest hundredth. Some people will say nearest tenth, which would be 0.1. And some will want you to put this in simplest radical form. It depends on what your teacher wants, how you're going to write this. Interesting idea over here. We have 25, so we had to break this into 12.5 and 12.5. We'd go through the exact same process we just went through there. An interesting thing for us to look at are something called Pythagorean triples. What this means is that if you have a triangle and you notice that some of the side lengths are, say, this is 3, this is 4, I can automatically go and tell you this length is going to be 5 if it's a right triangle. Any triangle with a 3 and a 4 is automatically going to have a 5. Any triangle that's a 5 and a 4 will automatically have a 3 there. That's what the beauty of a 3, 4, 5 Pythagorean triple will do. And it's not only that, but if I change this to 30, 40, and 50, that's still a right triangle. So any combination or any multiple of this, if I change this to even 500, 400, and 300, that's still a right triangle. It's just some ratio of the 3, 4, 5. And these are the ones that are listed here. These are four of the most common Pythagorean triples that you'll find. And for standardized tests, if you're one who wants to score well on them, you might find it helpful to memorize some of these to really help you out. And all you do is you memorize the top ones and try to recognize if there's some multiple of them, which are listed below. These are the most common Pythagorean triples, are in bold. Other triples are the result of multiplying each of the integers. So these guys below are just like, you know, times 2 or times 3 or times 4, something like that, times 10, whatever it might be. We'll take a look at this. It says that given the lengths of the two sides of a right triangle, all 3 side lengths of the triangle are integers and together form a Pythagorean triple. Find the length of the third side and tell whether it is a leg or a hypotenuse. So what we do is we look at this, 24 and 32, those are both divisible by 8, so that'd be 3, that'd be 4. I know that my third side is going to have to be 5. It's going to have to be of this ratio, so then since this was divide by 8, I'll have to multiply this by 8 to get 40, and the 5, since it's the longest side, this makes 40 the hypotenuse. We'll try the same method over here. 24 and 45 are both divisible by 3, so that'd give me 8 and 15. I look up above, 8, 15, 17 is what this guy is. 17 times 3 is 51. Since 17 is longer than 15 and 8, that would give me the hypotenuse. Same process works for this one. You probably get a leg, I would imagine. It says find the unknown side length. Write your answer in simplest radical form. What we're going to do here is we're just going to take a look at these guys. I'll just try the second one here just so you can get a hint at what some of this looks like. What I'll do first is I'll find this length based on this triangle, make sure it's a leg. Once I have A and 14, I'll find B, which is the hypotenuse. Once I have B, I'll use 32 and B in order to find X, which is this leg over here. So I'll just set this up to start off with. This is 24 squared equals 16 squared plus A squared. That gives me 320 equals A squared when I simplify this. And I'm actually going to use that A squared. You figure out that A is 8 radical 5, but we don't really need that. Because what I'll do is once I have this A value, I'll use it for this next triangle. And I'll basically say that 14 squared plus A squared, which is 320, has to equal B squared. So let's see, 14 squared plus 320, That sounds like it's going to be 516 is what b squared is going to equal. And you could go ahead and solve for b and find that it's 2 times 129 in a radical, but you don't really need that. We're again going to use this b squared just like we use the a squared of above. So we'll say that in this triangle now, 32 is the hypotenuse, so 32 squared is going to equal b squared, which is 516, plus x squared. I'll end up subtracting these to get x squared equaling 508. I'll then want to find this in simplest radical form. So x is going to equal 2 times the square root of 127. In case you need some help trying to find the radicals, there's a whole series of videos that help you find radicals. One method that someone showed me was this sort of T method where you take 508, you divide this by 2, and that gives you 254. You divide that by 2, and that gives you 127. 127 is actually a prime number, so what you do is you look for pairs. That's a pair of 2s, that goes on the outside, and whatever is prime or does not have a pair actually goes back on the inside. So that's one way to work with radicals. There's a whole series of about 6 videos that actually goes through some different methods. You can check those out on my blog or on Vimeo itself for JJ Nowinski. Lastly, we'll look at some story problems. I think these are really helpful for us to look at, seeing how we might use this. It says a farmer is planning on cultivating a triangular plot of land in the shown diagram. The plot has an area of 12,600 square feet. So with this, since we know that area equals 1/2 base times height, we can say that 12,600 is going to equal 1/2. Our base here is 7x, and our height is 4x. That means that 1260 is going to equal, well, 1/2 times 7 times 4 would be 14x squared. If I divide both sides by 14, that would equal 900. Or in other words, that x is going to equal plus or minus 30. But since we're dealing with lengths, we're just going to stick with plus 30. When I substitute that in here, 4 times 30, that would give me 120 here. 30 times 7 would give me 210 feet here. It says find the perimeter of the land, so what I really need to do is I need to end up finding this hypotenuse over here and see when that equals. So I'll do that next. I guess I'll do that right down here. We'll say 120 squared plus 210 squared has to equal this hypotenuse squared. When I do that, let's see. When I do that, I have some really big numbers. Let's see, 120 squared would be 14,400. When I add that to 210 squared, I get yet another big number. Let me just add these together really quickly. For some reason my calculator's not working. So I would have 58,500 equals my hypotenuse squared. And when I take the square root of that, since I'm working with sort of a story problem here, I think it's okay to use some decimals for this. So we'll say 241.87. So 241.87. If we're going to find the perimeter, what we're going to do is we're just going to add these 3 numbers together. So 120 plus 210 plus this last hypotenuse we found, we'll find that that's going to be approximately 570, I'm going to say 572 feet all the way around. Probably that's to the nearest, that is the nearest foot. That's probably what you're going to want. Again, some teachers might want you to round differently or use exact numbers. Make sure to watch that. Next, it has us do some sort of conversion. It says 1 acre of land is equivalent to 43,560 square feet. How many acres is this plot of land? Well, we were told that this is 12,600, so we'll divide that by 43,560. This tells us to round to 2 decimal places, so when you just put that in your calculator, you should get 0.29 acres, which is a really small plot of land to be farming. Maybe he's farming it by hand or something else. The farmer wants to include this land in a fence. A post will be placed every 12 feet around the perimeter. About how many posts are needed? You simply take 572, we'll divide that by 12 feet around, and we get right around 48 posts when we round up. It's not exact, but you know, when you're building a fence, sometimes you have to put a gate in and everything else. So this is not an exact problem, but it's kind of a neat way that you could apply this to these problems. Again, we're looking at Pythagorean theorem and its converse. If you have any questions, make sure to let me know.